Welcome back to this system design interview series. Today's topic under system design pattern is Gatekeeper. We'll cover what does this pattern recommends, what are the different design considerations, when to use this pattern, when not to, and finally an evaluation against the 5 pillars of system design. Gatekeeper pattern suggests to protect applications and services by using a dedicated host instance to broker requests between clients and applications or services. Let's look at the problem context which this pattern tries to address. Cloud services expose their core capabilities through APIs triggered via endpoints. These endpoints are publicly exposed. APIs interact with all or almost every different internal services, including storage. In case endpoints are compromised, can lead to a data breach or an entire host breach. Now this gatekeeper pattern, what it suggests is separating out a different host in itself which will take care of validating as well as sanitizing any request which appears into the system, keeping all the services aloof from this entire responsibility, be it application services or be it any of the responsible storage services. If you look at this particular diagram here, a high level depiction of this particular pattern is done where a gatekeeper ensures that only an authenticated, validated, and sanitized request reaches to an application or internal service and or any of the storage services also. So what are the different design considerations which we need to keep in mind if we want to evaluate this particular pattern? Internal or protected endpoints. Trusted hosts should not expose a publicly accessible endpoint. Any and every internal endpoint or API which is getting catered to an endpoint should be an internal endpoint, and Gatekeeper is the one which should create an interface which should work as an external interface on behalf of the internal endpoint. Minimum or limited privilege mode. Gatekeeper should execute with only minimum or limited privileges required to smooth functioning of the gatekeeper. No extra privileges should be applied. Single responsibility principle of gatekeeper. Gatekeeper's only functionality should be to ensure validated and sanitized requests reach internal ecosystem. None or no other service or a feature should be added to this gatekeeper's functionality. Encrypted internal communications. Gatekeeper to any internal service interaction should be preferably over encrypted traffic to restrict access. In cloud world, even these internal services are actually on the cloud. So there's a potential of a breach, and in that case, if internal communications are not over an encrypted channel, there's a possibility of them getting exposed, the internal communications getting exposed to the sub attackers, and then system getting compromised. Additional hop. Gatekeeper adds another hop in the entire network when the requests are coming from an endpoint or end client to this particular application or service. Hops introduce a latency which can impact the performance of the overall system. So evaluation with this consideration should be done whether the application or service being designed needs this kind of a gatekeeper pattern or not. Single point of failure. Gatekeeper being the first one in line where the requests land from the client, it can in itself become a single point of failure. So, one of the design considerations which needs to be ensured is that Gatekeeper doesn't become a single point of a failure, and there should be some level of failure resistance or high availability for Gatekeeper be in place. When to use this particular pattern? When application is handling sensitive information. Services which need an extra layer of shield in case the services are dealing with very confidential data or a confidential transaction data or any such thing. So in those cases, services which may be catering to these kind of requirements need an extra layer of shield. High priority and mission critical operations which cannot be disrupted. Any kind of mission critical operations which should not be or should not get disrupted needs can be put under this gatekeeper pattern. Request validation needs to be performed separately. If a overloaded system is there with high volume of traffic coming in, a lot of users, daily active users being in there, the system can be overloaded with catering to the different features where request validation and any sanitizations to be performed become a secondary from an feature aspect of it. So in that case, request validation should be moved out as a separate one to ensure that that particular service which is providing request validation can be scalable, independent, and should be in a decoupled architecture fashion. With this, I'll jump to the pillar of evaluation against the five pillars. Reliability, it has no major impact on it. Security, this pattern definitely helps enhance the security. With this pattern, implementing a new set of security policies becomes easier. Consider your application is already on production and there's a new set of policies which are important from security breach perspective needs to be put in place. If this pattern, gatekeeper pattern is in place without disrupting the actual application, the business functionality, the policies can get applied at the edge device or the gatekeeper device. Performance, rate limiting, throttling, and different other mechanisms which are required for managing a high scale application can be implemented through this particular pattern. Operational excellence and cost optimization. Cost optimization gets impacted because we are having an extra layer implemented. Extra layer always comes with an extra cost, but what it brings is an overall enhanced operational excellence. As security is enhanced, overall any kind of explainability or managing these security attacks or breaches against the application gets improved, and overall operational excellence gets impacted positively. With this, I'll quickly end this particular session on Gatekeeper. I'll be taking a few more other different system design patterns in my subsequent sessions. Till then, happy learning. Bye bye.